All right, I see a couple people starting to hop on. We are just going to get started at the top of the hour. So just in a couple minutes, we'll get started here. All right, like I said, we're going to get started here at the top of the hour as we see you all joining in. Thank you. Welcome. All right, Ben, it's the top of the hour. So if you want to get started.
Great. Well, thank you all for joining us today. Welcome to TRC's UN Edge pre-conversion, pre-migration webinar. I'm Ben Dwinal, Director of Solution Architecture here at TRC, joined by Brittany Mattern. She's our marketing coordinator, and she'll be moderating today's session. We're going to start out today's session with a review of our four-phase strategy for UN migration success. Then we'll go into the specifics of pre-migration phase and strategies and activities. We dive into the agenda here for today. I'm going to hand it to Brittany and let her just go over some instructions for today's webinar.
Of course. Thank you, Ben. Welcome everyone to today's session. The chat is disabled, but as we move through the content, please feel free to drop any questions in the Q&A box. After each section, we'll pause to address one or two relevant questions, and we'll also have a dedicated Q&A at the end of the webinar. If we aren't able to get to your question during the session, we'll be sure to follow up with you directly afterwards. We will also be launching a quick interactive poll during the webinar, so keep an eye out for that on your screen. With that, let's dive in.
All right. So as mentioned, we're going to start out today with a quick review of our UN Edge four-phase strategy for UN migration success. Then we're going to look at the key processes and activities in our pre-conversion phase. We'll pause briefly for a quick participant survey. Then we're going to dive into the details of schema mapping and pilot migrations. We're going to look at strategies for evaluating and prioritizing your data errors and planning for your data remediation and data cleanup efforts. Lastly, we're going to talk about key considerations and planning to define your release strategy. And then we'll wrap up today with a Q&A session. So as mentioned, wanted to do a quick review of, sorry about that, I think my wire hit that. Do a quick review of our four-phase strategy for UN migration success. For those that are really not familiar with our strategy, it's a strategy that we've developed over the last 8 years executing UN migrations. And what's really involved is a combination of best practices, techniques, strategies, and automated tools that help our project teams and our client organizations migrate to the UN efficiently, with precision, and with improved delivery reliability. Now, why have we separated it into 4 phases is a question we typically get. And really the first reason is schedule and execution flexibility. These phases can be executed collectively as phases as part of a long-term project, or they can be executed independently. And we've seen this as some organizations want to execute the assessment phase, maybe well in advance of pre-conversion and conversion, to get ahead of maybe infrastructure upgrades or data issues that they need to remediate. The second reason we've broken this into multiple phases really is around planning efficiency and optimizing resource scheduling for our clients. Helping our clients understand the processes that we're going to execute throughout the migration. It's going to support more efficient planning and scheduling of your resources on the project. A good example is if we know or we can communicate exactly when data cleanup is going to occur in the schedule, that's going to help our clients identify and schedule resources needed to support that activity very efficiently and effectively. Another example that we typically see is during, the schema mapping and data modeling and design phase of the project, we know we're going to need access to subject matter experts. And so being able to clearly communicate when those activities are going to happen in what phase is really helpful in planning out resources and being effective and efficient in our planning for the project. Great. Let's move on to some pre-conversion activities. So before we dive into the details, and I'll leave the screen up so everyone, can kind of see and read through some of the content. But before we dive into these details, we're really curious about where all of you are in your UN migration journey. I'm going to hand it over to Brittany to execute a quick audience survey here.
All right, everybody, it's time for our interactive poll. I'll leave this open as Ben discusses pre-conversion activities, but we're just curious to know, where is your organization at in your journey to migrating to the UN? Are you in planning? Are you in an active assessment phase? Are you executing, or have you completed your release and you're just looking to get more out of your deployment and investment? Like I said, I'll keep this open while Ben discusses pre-conversion activities. Back to you, Ben.
So looking at our pre-conversion specific activities, we want to find ways to be able to design your modeling, deal with data errors, mitigate those data errors, and prepare for release as efficiently and effectively as we can. And that's really where we've come up with defined activities for this phase. And this list is not all inclusive. There's other activities that will occur, but these are pretty common to most of our UN migrations. And so we've called these out as things that you're going to want to execute after your assessment phase. You've assessed your data, your infrastructure, and now you're ready to really dive into the design of your new model and your new solution. So we really want to start with schema mapping. And this is going to really define how your legacy data is translated into the UN data model. We then use these schema maps to run pilot migrations on subsets of your network data. And this is going to be to define how effective our mapping is, as well as help us identify where errors are that we have to deal with prior to getting to the conversion phase. Once we get through pilot migrations, we have a good handle on what data has to be cleaned up or adjusted in preparation for movement to the UN. And so this is going to put us in a good position to have that understanding and execute our data remediation and data cleanup. And then lastly, we've got to select and define the UN release strategy. This is critical planning that has to be done prior to doing any testing in any of your UN release planning. So selecting that UN release strategy is a key activity that we always execute. There are several strategies out there for UN releasing. We'll go through, I think, 3 of the most common we're going to cover today and talk through, the pros and cons of each. Great. Maybe before moving on, Brittany, I'm not seeing any updates. I don't know if maybe those on the call haven't put anything in, but I didn't see it come through.
I'm I'm ending the poll now, so those results
Okay,
should pop up on your screen. It looks like we
great.
swept the board with everyone's in the planning phase, so this is definitely going to be a great webinar
Great.
for that. And we also did have a question in the chat. So are there recommended timelines or sequencing for utilities with multiple legacy systems or service territories?
Excellent question. And we actually cover in UN release planning and pilot migration section discussing multiple legacy systems as well as multiple service territories. So we're going to touch on this point. Now, when we talk about recommended timelines, it's very specific for an organization's direct requirements or their needs. And there's a couple of key factors that I would point to, Brittany, with regards to that. Multiple legacy systems. Certainly, we need to identify that early on. If data from more than one system has to be converted to the UN, we're also executing consolidation, not just conversion. So there's more activities that have to happen. So in those cases, yes, we either have to run parallel activities with heavy coordination between them with a larger team, or we have to extend schedule a bit to account for that. With multiple service territories, I'll talk about this directly in pilot migration and UN release planning. However, we've done that multiple ways. With multiple service territories, you can migrate in what we consider a phased or iterative release plan, which might stretch out schedule but reduce risk on your overall release. However, we have run, like some organizations with multiple commodities, we've run parallel work streams in coincidence with a single release to account for that. So it's not always schedule that impacts. Resources can go up or down to meet schedule, but that's really a part of understanding your organizational needs to get through that planning.
Awesome. Thanks, Ben.
Excellent. Okay, let's dive into some schema mapping. So in designing or defining how the data is going to translate from your legacy system to the new UN model, schema mapping is critical, and having the sequences of activities that need to occur and having some key considerations in mind as you approach schema mapping is very important to be efficient and effective during this process. If we don't get this right, we end up with rework or redesign of the model down the line, which can be costly and cause some schedule delays. So we want to make sure we're getting this right. So in schema mapping, as you go into mapping your schema, there's a couple of high-level considerations that we want to account for. First of all, we want to focus on mapping to the foundational models that Esri provides. Now, this is very important because the closer that you can stay to the foundational model, it's going to provide better opportunities for you in the future for upgrades, enhancements, and applying innovation and adaptations to your system. Now, it's unlikely that your organizational requirements are going to fit nicely and neatly into the foundational model without adjustments. So what we want to take into account there is if you do need to adapt that foundational model, we want to extend with additive change that foundational model. That way, it still keeps us in line with the utility network management release plan. It keeps us in line with future upgrades. And we can document exactly what additive change has happened. So we know exactly what's new, what's outside of the foundational model, but keeping good track is very important. Secondly, and the preceding question was a great precursor to this, we want to know early on as part of schema mapping is all of the data coming from a single legacy system or multiple sources. That's very important because we need to understand how we get access to that data, how it maps in, and how it becomes part of our automated processing for converting your data. So knowing where data and integrated systems sit, that has to be part of the UN conversion is very important. Lastly, I would say another key consideration is make sure the team that you're working with is using data comparison tools to really jumpstart your schema mapping process. There's automations out there that can compare your legacy system to the UN model and find suggestions for pretty normal fits of maybe field names or class names. We can find those, and within TRC, we use our Carmen tool set to do some of these activities, but it's really going to be able to suggest typical and object mapping for you to give you a head start on your schema mapping process, right? Great example of this is in legacy models on a device asset class, we might see something like status field, right? Well, that's going to make sense to us to just automatically map that to lifecycle status in the UN schema, right? We're going to find those, automatically put those in so that when we're starting out schema mapping and reviewing those mappings, we've already got a jump start on it, making it more efficient and easier for the project. Executing your schema mapping, once you get past that phase, it really starts with an initial focus on object level or class level mapping to get the structural mappings defined between the systems. Next, we drill down a bit into mapping assets and subtypes from your legacy systems into the UN asset groups and asset types. We continue to drill down from there, and now we're looking at data field, and attribute level mappings. We also want to consider how non-spatial elements of your data are going to come across, how they get mapped into the schema. And this is where really thinking about how your schema mapping occurs is important with non-spatial content specifically, because non-spatial content can simply come over as related items. However, if we want those items to participate in things like output from a tracing operation or be included in a subnetwork export, which is required for a lot of your data integrations, then we've got to make sure that comes across with associations, right? So this is where getting ahead of some of these things and understanding how you want to deal with these elements is important. I think lastly, I'll point out is historical data schema seems to come up pretty often, and we execute it on most of our projects, and that has quickly become a section of our schema mapping. We're not just mapping your existing UN model or your existing data model into the UN model. We're accounting for historical records. We're accounting for other content that has to come over and is critical to the success of your migration. Now, from our experience, there's a lot of additional considerations that you want to take into schema mapping. As you dive in and in-depth evaluation of your models, this is a great opportunity to identify any pain points you have in your model structure or your data values. It's a great opportunity to simplify where you can, or possibly add more detail to critical assets where needed to support UN and UN operations. Our team likes to refer to it as scenarios of data you wish you had. Yeah, we want to account for that as part of our schema mapping process. There's a lot of areas with legacy systems that we typically see are not high enough fidelity to support UN operations. So in those cases, we're going to recommend as part of schema mapping to improve the fidelity of your data, add more detail. On the flip side of that, we also find areas where there's data you no longer need that we can prune out of your legacy data systems, making it more efficient where possible. If you look at our mapping spreadsheets, in most cases, they're going to be loaded with don't migrate tags just for this process alone. The last thing I'll point out with schema mapping is as you're heading into it, focus on key data elements that the UN needs to be built and to operate your key analyses, right? I would typically point to things like, attributes like life cycle status or phase or material. Those are all, or pressure. Those are all things that if there's missing values there, if there's things aren't mapping across correctly, it's gonna hinder the process and cause rework down the line. So as you can see, and just to kind of wrap up schema mapping, this process can really provide more details to have a refined migration where you can go to a hybrid model of adopting more low fidelity mapping where you can to prune out data you don't need, and then adopting more high fidelity mapping where you need it so you can take advantage of the high value analysis provided by the utility network.
Hey, Ben,
Great.
we did have a question on schema
Oh,
mapping before we move on
okay.
to that. How do we approach schema mapping when we have years of inconsistent or siloed data across departments?
That's a great leading question. So schema mapping, we're really focused on the structural components of how things map across. Once we get into pilot conversions, that's when we're really focused on the content within that schema and how to deal with it. Pilot conversions is really meant to get into the details of what data exists. So there's really two places where we focus on quality of data. That's going to be in assessment, and pilot migration is when we get into the quality of the data. Now, as a precursor to my next topic, Brittany, I'll just point out that typically how we deal with those things, differences in quality, is when we're running pilot migrations, we're going to select multiple areas across multiple regions or multiple commodities as part of those pilot migrations because we know there's going to be variability in quality. And so we want to experience as many data conditions as we can early on in the project so that we can weed out any of those quality issues.
Totally. Awesome. That's all we had for questions if you want to move on to the next topic.
So after you've got your initial schema mapping defined, you've gone through initial data assessments, got modeling in place. This is the perfect point that we want to run pilot migrations. Your pilot migrations are very important. They're going to initially test the effectiveness of your data mappings that you've defined. They're also going to test the ability of your conversion tools to automate your conversion process. One of the key outputs for your pilot migrations that you need is a good understanding of the types of data errors that you're going to face, the types of quality issues you're going to face, and it sets you up for your data cleanup and data remediation activities. So I'm just going to go through some of the key considerations here for your pilot migrations. And having these in place are really going to help you optimize your pilot migrations, as well as maximize the value of your output from your pilot migrations by using some of these strategies. So, we would start our pilot migrations by, as the last question that came in, kind of led me to was, how do we define what data we're going to run pilots on? So we want to select pilot areas that are a good representation of the data conditions we're going to find across your enterprise. And so selecting maybe multiple small segments at the circuit level, feeder level, or maybe pressure system, or maybe individual network segments, we're going to want to select multiple in different locations with different densities, with different environmental conditions. We're going to want to find those sections that have a good representation of the data variability that we may encounter. So in this case, typically we find data variability across different jurisdictions or different business entities within an organization. We're going to want subsets of data from both of those as part of our pilot. That's really important for us to make sure we understand the variability in data quality, and we're increasing the opportunity to encounter data errors that represent the full scope of your data early on in the project. Secondly, once you define your segments, we're going to want to isolate data processing pipelines for each section of data. This is really important, and this gets down to that accounting for data quality variability. As we start our pilot migrations, we have a schedule in mind that we want to hit. On any individual segment of data that we're running through the pilot process, we might hit some data issues that take time to resolve. However, we don't want that one section of data to slow down our pilot schedule, or getting value or getting returns on UN errors that we need. So we're going to make sure we segment them. We're going to extract the data independently. We're going to load it into the asset packages separately. We're going to enable topology, validate topology, run all these processes for building UN as independent processes. That way, we don't encounter any bottlenecks in our pilot migration because of data quality issues. The other thing that this does is for those data sets that are a bit cleaner, it allows much faster cycle times. We can cycle very quickly on, hey, we encountered a small data issue. We can resolve that. We can rerun it and see the output. So it gives us much faster cycle times as well. Now, the other benefit for isolating your processing on your subsets of data during pilot migration is that we're able to capture very refined metrics about the processes. So as we prepare for our planning for running on your full data set, what we're going to want to know is, hey, how long does the extract from the legacy system take against this volume of data? How long does it take to translate it into the UN model with our automated routines? Those are things that we need to know. How long does it take to load the asset package or enable topology? Those are key factors for planning our release down the line. So we're going to want to make sure we isolate so we can capture metrics. Another key thing is capturing and evaluating data errors. Going into your pilot migration, you're going to want to have a good plan in place for how you're going to evaluate and review data errors. Initial migrations, you can have a high error count, and that's pretty normal because we see typical misplacements of objects in legacy systems that don't align with how the UN do it. Pretty normal, but we've got to have a good way to deal with those and evaluate those errors. Some of the error counts that we want to get typically are asset counts for both extracted and converted features. We're going to want to know how many geometry errors we have versus how many connectivity errors we have. We're going to want to identify where missing or blank fields in critical data elements exist. Having all of this information is going to help your data cleanup planning be way more effective and efficient. Now, deploying the UN and running your pilot migration is not just about your data. As part of your pilot migration, you're going to want to take it beyond just data conversion and getting it into the UN. We're going to want to take it all the way through publishing UN services, do simple edit tests. This is really going to help you uncover more detail about your data model and your data quality and how it can fit into your existing requirements. By taking small amounts of data through the entire process, it's going to help you identify all the possible configuration adjustments we need to make. There may be things in the data model or data values that exist that maybe block me from getting a map display the way I want it to work. So we want to uncover those things buried down in the UI tier. We want to uncover those as early as we can during pilot migrations, and we can only do that by completing the configurations in the pilot. Lastly, the tail end of a pilot migration. Once we stabilized our schema mapping, we know it runs through our automated processes for conversion, and we know we can get at least an early build of the UN. This is a great point as you're finishing up your pilot to do a test run against a larger volume of data and capture metrics. In some cases, you may want to run it against your full set of data just to see what types of errors you may encounter that weren't represented in your pilot. And also what sort of durations you get with your major steps. I mean, the critical steps that we want to know is extraction, conversion, and enable topology. If we can get metrics on those, it's hugely valuable taking into your planning for your final release.
So Ben, how many pilot
Yeah.
migrations would you typically deploy / recommend that you deploy? And how do you choose which data to test first? It seemed like you talked a lot about multiple different data sets, but how do you prioritize that?
Sure. So again, there's a lot of factors specific to organizations that can sway those decisions. Now, how many pilot migrations are we going to operate? It's really how many subsets of data are we going to run through the process, I think is a better way to think about it. So like, let's take a single commodity, multi-jurisdiction electric distribution organization. If they had 3 jurisdictions, likely we would pick 1 to 2 small segments per jurisdiction. That's a good way to look at it. That way we feel like we're covering a good representation of the full set of data that we're going to encounter during the release. But we're not ballooning the data volume to the point where we can't process quickly and execute our pilot migrations very quickly. Now, when it comes to testing data, again, the migration may include other types of data such as land-based data or historical content. We're really going to focus our testing on things that are important or needed or required by the utility network as a first approach to testing anything.
Awesome.
All right, so you've taken it through schema mapping, you've run your pilot migrations, and now you've got a whole bunch of error reports and data remediation reports you have to deal with. Where do you go from here? So a key part of the strategy is knowing how you're going to evaluate those errors. How are you going to slice them? How are you going to prioritize them? What is the best way to approach them to prepare for data remediation planning and cleanup? Many organizations have reporting tools that they want to use, and certainly your UN reports, your data assessment reports can all flow into your enterprise standard tools. I know in a lot of cases we'll use Power BI or Tableau or other enterprise level reporting engines to support evaluating what these errors mean and what the distribution of errors are. And when we talk about evaluating your errors, we're really talking about looking at it from the standpoint of, hey, how many missing data values do I have? How many geometry errors, connectivity errors? How many times do I see things where we have like intersecting lines or corrupt geometries or null geometries? We really want to understand and slice the data as quickly as we can so that we can dive into the fixes faster. So some key aspects that I mentioned before is looking at your source to target, pre and post conversion, right? So having metrics for your errors about total feature counts, meaning, okay, my source, I had this many. How does that relate to what came out? What are the assets counts on the other side and how do they relate? Knowing how you're going to evaluate that is an important factor. So you're not missing any in translation that get dropped somewhere. Knowing what percentage of your data errors are, let's say, stacked geometry that we can fix very quickly with automation, that could be 50% of your errors. And so knowing that out of the gates is gonna help you say, well, I have 500 errors, but 250 of them can be easily fixed in the next conversion because it's a simple geometry fix that we can adapt. On the other side, though, categorizing those errors is important because if we can't automate it, we have to identify how that's going to be resolved. So from our experience in evaluating error reports, using engines and reporting engines to slice and dice those error reports so you can categorize them, prioritize them. What we typically see is, in a lot of cases, that 80-20 or somewhere around there rule will apply. And what that really means is a large percentage of your data errors are generally produced by a very small number of issues, right? And going to the UN, a great example of this is like junction to edge errors that we see with connectivity rules. And so this is a classic example where in a legacy system, a device can sit along the midspan of a line without a connection point, and that's okay. But coming into the UN, that's an error, right? So that can happen thousands of times, but again, we can quickly identify and resolve that type of issues. Another thing we want to be aware of is, what things are in bulk, what things can be addressed with a simple fix. Maybe I can address 1,000 errors with one simple fix. And then that 20% side, there's a smaller percentage that we typically encounter that have data conditions that are a bit more complex. Maybe we need an additional translation routine to be developed to solve that in an automated fashion. In some cases, there may be manual intervention, but we've got to know that early on as part of our evaluation of our errors. So really the take home from this is having tools in place to effectively analyze the errors and assessments that come out of your pilot migration, so you can efficiently plan your data cleanup and data migration activities, is critical, to optimize the process.
We did have one question come through in the chat, Ben, so I'm going to ask that now.
Okay.
What types of
Sure.
data errors or system conflicts are the most common that you see coming out of these reports?
Yes, excellent question. So when we look at different types of errors, so geometry errors are a classic example of something we're looking for them. We have a list within our modules, our TRC module, that we're looking for in every migration that we do. One of the common ones that we see is you stack geometry or stack points. Pretty classic in legacy systems to allow geometries to be coincident, but in the UN, we're not allowed to do that. So we typically have ways of dealing with this, like offset routines. Other things that we see, null geometries is something we see quite often. Multi-part geometries is something we have to deal with, or multi-line geometries. Corrupt geometries is very common. So that's we have a whole slew of geometry errors that we're looking for built into our Karman modules, that as part of assessment, we're just going to look for. Then it's kind of the drill down, right? Once we can deal with geometry errors, we're looking at things like, things that conflict with connectivity rules. Classic examples that are, again, pretty easy for us to identify and fix. In an electric system where service lines are connecting to secondary lines, there may not be the need for a connection point to be there. It can connect directly to the line. In the UN, that's an error, right? So we can see that high volume because it's an actual standard or practice in the legacy system. So we see a lot of errors that we can deal with very, very quickly just because it's a standard practice. We know how to deal with it. We know how the UN rule works, and we can apply that fix. Now, when we get down to attribute data values and domains, it gets a little trickier. And I can kind of talk through this real briefly. I don't want to go into too much depth, but in legacy systems, historically, domains may not have been widely used to input data values. And so what we encounter a lot of times is we'll see the name for a material that has been typed, not selected from a drop-down list, and it's been spelt 7 different ways, right? So again, because we're aware of these conditions consistently coming up project after project, we've built in configurations and automations to be able to support identifying these things and helping the process be more efficient to deal with these errors.
Awesome.
So now you've evaluated your errors, and you're now looking at planning your data remediation efforts. And how do you want to do that so you can be effective, efficient, with resources, tools? How do you do that and get it right? So as I mentioned in the last slide, the first step is having a good process to evaluate and identify and categorize your errors and issue types, right? As I mentioned, geometry error is a much different fix than potentially identifying a connectivity error and how to solve that. We want to get to those high volume errors quickly, right? Things that we can fix quickly, get those out of the way so we can focus on the more complex issues. One of the ways that you want to do it when you get into data remediation is we have to categorize your errors by fix type. This is very important. And there's two, clear ways that, and there's others, but two clear ways that I'll point this out. When I say fix type, we're going to want to know immediately what we think is an automated fix versus potentially manual, or needing input from subject matter experts, because properties, missing data values that we can't simply solve because of the importance to your operations and your business processes. We're going to need to go back and ask questions. And so we've got to identify those as early on as we can, so we have a little bit longer time span in the schedule to address those. The automated fixes are great. We know we can fix them, we can automate them. That moves very quickly, but we've got to identify those things that maybe take a little bit longer. Secondly, we've really got to know if we're fixing data or adapting it, or if we're generating it. We've seen many cases, and we encounter this often, where data values needed for the UN were not captured or are not present. And so again, that's another area where, okay, wow, we've really got to come up with a plan to how we're going to get that data generated so that it's accurate and it fits and it's going to be ready for, your go live for the UN. Once you've categorized your data, now you need to determine exactly how you're going to resolve them, right? As I mentioned, some errors may be more complex. Some errors you may need specific tools to be able to fix. So again, knowing what types of errors you have, how you're going to fix them, and what the options are to fix them is a key part of the planning process you want to go through early on for your data remediation. Some things you may not think about out of the gates when you think about data cleanup is, where are you going to fix the data? Is it better, in certain data you may want to start early and start fixing in your legacy systems. That may make sense. There may be other data elements that we can easily pick off with a conversion routine that we can incorporate as part of the conversion. There may be other data errors that are more on the UN configuration side that we may handle as a bulk update to resolve as a post-migration activity. So really determining where you're going to fix it is important. I would say the next thing is, and I kind of touched on this, is the when. When do you fix it is probably the last question you want to ask, is how do we schedule those fixes? In many cases, if we're fixing them in legacy systems, they can start way before conversion. Actually, we'd want them to start as far left in your project as we can get them to. So really understanding the where, the when, and the how of your data fixes early on in your remediation effort is going to make the process significantly more effective for you.
And that actually leads into one of the questions that we got in the chat. What's the risk if companies only remediate critical errors and just leave the rest?
Yeah, that's so typically as we initiate our projects and we initiate this in assessment and we carry it into pre-conversion, when we start to talk about categorizing errors and prioritizing, we also assign severity to those errors, right? What we can do, our team can quickly help on things like, hey, we know this type of error is high priority because it's needed to build the UN. It's needed to get to things like subnetwork creation, so that we can execute functionality we needed for downstream systems in reporting. So we're going to prioritize those. We're going to assign severity levels. And typically the way that we approach it is anything that we identify as a high priority would have to be part of the release, right? That has to be solved as part of the release because it's critical for UN functionality that supports downstream systems, right? Critical compliance reporting, subnetwork exporting for, maybe an ADMS integration, tracing output, clean editing values, things like that, we're going to put as a high priority. Other factors that we may want to make medium priority that we can deal with is bulk updates. And then low priority, we typically say these are things that can be cleaned up over time, that we can address as part of the normal editing and maintenance of the system. Great. So another key activity, which again takes us a little bit away from data, but is very critical to understand and have a good strategy for early on in your project, is looking at what's your release strategy. Now, we've executed all of these types of release strategies, and so I'll kind of focus on these three here. And it breaks down into these categories. It's either a direct conversion or a cutover. We may run a release with parallel running systems, or we may have an iterative or phased release plan. But selecting the right approach for your organization does take some planning. It takes some coordination in looking at other systems. And how you can do this effectively for your organization that aligns with your business goals and your IT objectives as well. So let's talk specifically about direct conversions. So direct conversions or cutovers, right? We're moving all of the data applications and repointing integrations, reporting everything all at once. It's one move. We typically see this used in single region or single commodity organizations, or with organizations that have a legacy system that is being retired or no longer supported. It's kind of a forced migration. That's when we see some of these direct conversions. Now, some of the pros of a direct conversion would be, efficiency of post cutover. You're not maintaining two systems in a direct cutover, right? You're only maintaining the target system moving forward. A second benefit is you can retire those legacy systems quickly. And maybe a third would be you can maximize your investments in your migration to the UN by focusing completely on that as your main system. Maybe some of the downsides with the direct conversions would be complexity and risk for the release. Knowing that you have to move all integrations, all reporting, everything at once alongside your GIS, it increases the complexity of that move. So that's kind of maybe a downside. I would say another downside is your cutover window may be a little bit longer or quite a bit longer than if you're doing an iterative release or a parallel system. So that's just thinking through some of the different factors of it. Now, with parallel running systems, in this case, we're going to migrate data from a legacy systems to the UN without necessarily moving all the applications or reporting or integrations to downstream systems. So now with a parallel system, we typically couple this with some sort of a temporary synchronization mechanism that's going to either sync things from the legacy system out to the UN or the UN back to the legacy systems. In some cases, we do see two-way syncs, although those can be fairly complex. Now, when do we typically see these type of parallel running systems? We typically see this release strategy used when the complexity of a single move is too high or too risky for a business or an organization. Integrated systems, the complexity of those integrations are too much to move it all at once, so they'll choose a parallel running system. Going in this path can reduce your risk a little bit because you're not having to move everything, but it does increase your overhead a little bit. So let's talk about maybe pros and cons of this approach. The pro, it reduces the risk on the release and the risk to downstream systems by having a parallel running system for your release plan. The downside, it's costly to maintain two systems using that approach. You have to implement a temporary data sync that has a lifespan on it. So you're investing in something that will only live on for the time that you're running this parallel system. So there is some downsides to this approach. Now, phased or iterative release plans, typically for one business entity, one jurisdiction, one geographic area, one commodity, we're typically moving all the data, applications, and operations over. This is very, very common in multi-region, multi-commodity organizations where there's clear business process separation or clear geographic boundaries exist, that we can kind of isolate different sections of data and systems. Now, this approach also reduces data volume, so you do get some speed factor here in your release because you're dealing with smaller data volumes. So with this type of release, what are we looking at? It reduces risks on the release, expedites the migration. It alleviates outages for your business entities as a whole. You can do it group by group, jurisdiction by jurisdiction. Downsides, you're continuing to maintain two systems. Extending migration schedules typically involved in multiple releases. And then the big factor with the phased release plan is, when do you consolidate? Is it part of conversion, or do you make that a secondary effort? So just some key factors around the release planning. And you can see why this is so important and very critical that your release plan, you've selected it, it's well-defined as part of a pre-conversion phase activity. It plays into how you approach your data remediation, how you approach your dress rehearsals as you prepare for your release. So making sure that you have a good release plan is very critical. Great. So I think we've gotten through all the phases. I'll hand it back to Brittany. I think we're going to open it up for some questions.
Yeah, we've got about 9 minutes left, and there is one question open in the chat so far. Can we switch strategies mid-project if our timeline or resources change?
Maybe I'll leave that slide up for this question. So the answer is yes. However, there's a lot of factors that could play into that. Typically, if I select a direct conversion and consolidation for, let's say, a multi-commodity or multi-region organization, I would have the opportunity to potentially switch to a multi-release plan with little adjustments, right, for those initial releases. However, it would extend schedule, right? So there'd be impacts and adjustments all around those decisions. Certainly planning for parallel systems and rolling out the infrastructure to support that, and then deciding another path, it could be challenging. But again, there's so many factors and so many ways you could address those challenges to narrow down the impacts. I think the answer is yes, you can. Just keep in mind, it may adjust schedule, it may adjust resources to complete the project. There may be a lot of factors in and around the project that we'll have to deal with.
And I think that's what makes these first two phases of our four-phased approach so important, because it's likely they would see those potential changes because we took so much time planning. Is that right?
Yes, yes, absolutely. And in a lot of cases, Brittany, in the first, few migrations we did back in 2017, 2018, maybe this wasn't something we got to until conversion. We didn't
Right.
front load the UN release plan. We weren't maybe thinking through all the factors. And so that presented some challenges for it. And that's why we've structured it exactly the way we have, why we've scheduled UN release planning as part of pre-conversion, because it does have an impact on how you approach so many other activities and scheduling and resources, that it's important to get it selected and defined early on.
Totally. Okay, I'm not seeing any other questions in the chat, so maybe we'll wrap up here. We wanted to thank you all for attending, and we will be doing a webinar on phase 3 of our 4-phase release plan, which is conversion. So look out for that in June. This webinar was recorded. So following the webinar, I will send the link out to this video for you guys to share with any of your colleagues, along with a link to to be able to download our UN Edge program one-pager. Ben, did you have any closing thoughts?
Thank everyone for attending. As Brittany mentioned, if you have questions, please reach out to us. We'd be glad to connect with you or just respond via email with any questions you might have. And yeah, thank you for attending.
Thanks, everybody.